Assalamu alaikum everyone. Today we will start Numerical 2.5 Kinematics Unit 2 Class 9th. Let us see the statement of this problem. A car moves with uniform velocity of 40 meters per second for 5 seconds. It comes to rest in the next 10 seconds with uniform deceleration. Find the deceleration and total distance traveled by the car. Now quickly enlist our given data. The car is moving with uniform acceleration, so this is the initial velocity of the car and it is 40 meters per second. The car is keep moving with this for the time of 5 seconds. Consider this box as a car. It is already moving with 40 meters per second velocity. That is the initial velocity, and it kept moving with this velocity for the time of 5 seconds and reaches a new position. Then the driver of the car applies brakes and the car started to decelerate and it comes to rest after 10 seconds. So when the car is at rest, its final velocity is 0 meter per second. So now we have two times in this problem. So to differentiate both, the first time was denoted as t1 and second one as t2. And what we have to find? We have to find the deceleration. The deceleration is simply the negative of the acceleration. When a car is slowing down, its acceleration is called the deceleration because acceleration was in the opposite to the direction of the velocity. So it is denoted by A, but it has a negative sign. So we have to calculate the deceleration and we have to calculate the distance that the car traveled during this whole journey. So because in the first part the car is moving with the uniform velocity, the value of the acceleration is 0 because there is no change in the velocity. So the acceleration was only changed in the second part of the numerical, where the velocity decreases from 40 meter per second to 0 meter per second within 10 seconds. So to calculate the deceleration, as we know that acceleration is equals to change of velocity. It means the final velocity minus the initial velocity divided by time. So A is equals to 0 minus 40 meters per second divided by 10 seconds, which is equals to negative 4 meter per second square. So this is the deceleration we have calculated here. The second thing, we have to calculate the distance. The car traveled the distance when it was moving with uniform velocity, the distance of this part, that is S1, and then the car travels the distance from when the brake was applied and started to decelerate. It also covers the distance in that part. It is denoted as S2. First we calculate the distance when the car was moving with uniform velocity. S is equals to V multiplied by T for uniform velocity. So S is equals to 40 meters per second multiplied by 5 seconds is equals to 200 meters. This is the S1. The distance that car travels when it was moving with uniform velocity for 5 seconds. Now to calculate the S2 when the car was decelerating, we use third equation of motion. 2as is equals to vf square minus vi square. By putting the values, S2 is also equals to 200 meter. The total distance that the car traveled during this journey is equals to S1 plus S2, which is equals to 200 plus 200 and equals to 400 meter. So that's all about numerical 2.5. If you understand this numerical, please share my video and like my video and subscribe my channel. Thank you very much.